Question 29, divide two integers. Given two integers, dividend and divisor, divide two integers without using multiplication, division, or mod operation, and return the quotient after dividing dividend by divisor. And we are going to assume that we are dealing with an environment that could only store integers within 32-bit signed integer, and this is the range that we have, -2 power 31 and 2 power 31 minus 1, and we're gonna stay within this range. So the question says if 10 is given and 3 is the divisor, we should return 10, but we are not going to just like divide it like normal operation that we have. We should do it like without using any of these. We can, one way to do that, which is going to be a brute force, we can minus this from the dividend as much as we are not going to get negative or 0, but that's going to be a problem for the time complexity. So the approach that we are going to take towards this problem is going to be a bitwise approach. So let me tell you what. First, we are going to deal with a special case. The special case is when, let's say, let me show you when we print power 2 by 31. Okay, the number that we get from here is this number, right? And keep this in mind that when we have the dividend equal to minus of this number, which is 2 power 31, right? And the divisor is minus 1, the number that we are going to get out of this is going to be positive of this number, right? But we have the limit here that it should be minus 1. So this is a very special case, and for dealing with that, what I'm going to do, I'm going to just put this here, and 48 is going to be 47. This is a special case, nothing about knowledge or anything like that here. We just deal with that with an if condition, right? And then what we are going to do now, it's time to actually bitwise divide dividend by divisor. For doing that, I'm going to say we have A, which is the dividend, we have B, which is the divisor, and we are going to have a result, right? So I'm going to put the absolute of the dividend here, and because we are not going to deal with negative numbers right now, at the end we are going to deal with that, and then I'm going to put divisor here, and I'm going to put 0 as the result. Then I'm going to have a for loop in range, and what range are we going to go through? 32 bits, because we are going to, like, the limit is 32, so I'm gonna go from 32 to all the way to 0, right? And the x here that we have, x is power, so 2 power x. So the x that we are like looping around, the for loop that we have, the x is the power, and we are doing it bitwise. So I'm pretty sure you remember that if we had, like, okay, let's say 3 number, this was 2 power 0, and this was 0, this was 1, and this was 2. So if we had 3 number, let's say we had a number with 3 digits, right? So this one was 2 power 0, 2 power 1, 2 power 2, right? So for example, the bitwise of number 3 is going to be 0, 1, 1. 2 power 0 is going to be 1, 2 power 1 is going to be 2, 2 plus 1 is going to be 3. So this is the bitwise of binary of number 3. The binary of number 3 is going to look like this, okay? It was just like something if you don't remember. And then what I'm going to do, I'm going to check the number A that I have. If I move it to the left x times, minus B is bigger than or equal to 0. So it's still positive, right? So if I deduct a shifted x times to the right minus b is bigger than or equal to 0. And if it is, I'm going to add to the result. I'm going to add to the result 1, but not just the regular one. I'm going to shift 1 x times to the left. And then I need to update a. And the way I do that, I'm going to say a minus, I'm not going to put regular b here. It's going to be b to, x times move to the left. And finally, we're done. That's it. We are done with this. And what I'm going to do, I'm going to say return result if dividend, right? If dividend is bigger than 0, is equal to divisor bigger than 0. And else I'm going to return the result minus result. The reason that we are putting equal like here, we are going to say if this is true and this is true, it means we have positive and positive number. We are going to return result. And if we have negative and negative number, minus multiply minus is going to be positive. So still we are going to return a positive result. And if it is not one of these cases, if they are not both true or if they are not both false, like either like we have one of them positive, the other one negative, we are going to multiply the result by negative. Let's run the code and see. Oh, I made a mistake here. Sorry, my bad. There we go. And I have a typo apparently. We should be very careful. The reason that I changed those to A and B is to make it simple. So now it says I have a mistake here. So let's find what we have done wrong. So the bitwise that we are doing, and then we are going to check if this minus b is bigger or equal to 0. And then I'm going to add 1 here and a minus b here, and then I'm going to return this if dividend is bigger than 0 or this is bigger than 0. So maybe I need to put parentheses here in case, because the problem is saying, as you see, the problem is with the negative here. So it has done it mostly right. So I should see if we have done something wrong here. There we go. So it was the parentheses. As you see, like sometimes like small thing that can cause your code gets like error messages. And as I promised, I got this solution from this gentleman here, Lee215, and there was no explanation here, so that's why I try to explain it here. So, and he has mentioned that the time complexity for this solution is 0.32. Thank you.